Alright, I'm going to do my best to explain this question. Unfortunately, it did not print the whole question, so I'm going to have to kind of walk you through it without specific numbers. I did put your specific numbers in my calculator so we can work through it with your numbers, but it only printed part A and B of the question. It didn't print the rest of the question. So I have it pulled up, but it'll be different numbers, so I'll try to be as non-confusing as possible. Even though these questions are they're long because they want you to do everything to the same set of data, so you don't have to keep entering data over and over again. The trouble is if you get one of the parts wrong, it resets with a whole new set of data. So try to be patient. If you get frustrated with these, kind of close them out, take a break, and go back to them. Because it's a lot of data entry, which I know is tedious and kind of annoying. And then it's a lot of parts to the question because they want you to have the same data set for the whole question. So bear with me if you can. I'm going to start with the numbers that were in the question you sent me. The first thing to do is to take the data. Hopefully you can see my calculator. So you want to put X in L1, Y in L2. And we're going to go to Stat, over to Calculate. I always choose option 4, linear regression. And you can go down till you get to number 4, or you can just push the number 4. Oops, sorry. And then enter. Make sure this is in the window. So your X's are in L1, your Y's are in L2. Frequency should always be nothing. Storing the regression equation you can do, but we don't really have to worry about that. And then you go down to Calculate. It looked like your numbers were close, so you might have mistyped. I know I mistyped one of them. So you want to be really careful when you go to Stat, and then Edit. And I know this is a little annoying, there'll only be one of these on the test. You really want to double check all the decimals. I know decimals are annoying to type in. And you want to make sure that the number on the left aligns with the number on the right. They should go together as a pair. Because they're related to each other. So, kind of annoying, yes. Double checking will save you frustration later, though. So once they're in there, you do stat calc 4. Oops, it erased. Stat calc 4. And then down to calculate. If you have an older calculator, I think you can just hit enter. It'll do it all, though. Sorry. It'll do it all automatically. So that is what we should have gotten here. 0.17, and that rounds to 7. And then X is variable, so the slope is attached to the variable, plus about 12.8. And it says to round to 1 decimal place as needed. So there's our slope equation. Sorry, not our slope equation, our full equation for the least squares regression line. You have your slope and your Y-intercept. Let me get a pen going here. Alright, so part A is just a matter of typing carefully. Again, put the X's in L1, put the Y's in L2, and then stat calc 4. And you got that data by clicking on there should have been like a little book or something right here. You click on that icon and the table pulls up. So part B says to interpret the slope and Y-intercept if appropriate. I'm interpreting the slope. So slope is how much Y changes every time X goes up by 1 unit. So X is the height in inches, Y is the head circumference in inches. So every time the height increases by 1 inch, the head circumference increases by 0.177 inches. So for every inch increase in height, the head circumference increases by, and you would put in, I think you can type it in, 0.177, and it says to round to 3 decimal places. So it says X goes up by 1, Y goes up or down by whatever. It would go down if it was negative, up if it was positive. It's always appropriate to interpret the slope, so it's never going to be this choice. It's always appropriate to interpret the slope. Now the y-intercept, which I think is part C, is 12.8. That means if there is no height, if the height or x is 0, so I'm going to write that down over here. If height is 0, does it make sense to have a head circumference of 12.8? If you have no height, you have no head circumference, because if you're a height of 0, you don't exist. So it does not make sense to interpret the y-intercept in this case, because that height of 0 is not appropriate. That means that it doesn't exist. So if you can bear with me here, I'm going to pull up a different file. The numbers are going to be a little different here, but the questions will be the same. So this is a different set of data, but it's the same questions. So again, interpret the y-intercept. In this case, it is not appropriate to interpret the y-intercept, because if your height is 0, then you have no head circumference. So part C says to use the regression equation to predict the head circumference of a child who is 24.25 inches tall. Now your question is going to have a different number here because I couldn't get your full question to print for some reason. So, oops, pull that back up. Okay, so you're going to take whatever the number is here, and you're going to plug it into your equation here. So you're going to type in, you don't have to type in the y equals part, just 0.177. You're going to multiply that. So that's multiplication. So that number multiplied by, sorry, it keeps closing, multiplied by whatever the number is here. Whatever that number is, plug it in for x, multiply it by the slope, and then add the y-intercept. Type all that in at once in the calculator, not the y equals part, and whatever you get is the answer. So that is using your regression equation to make a prediction. So take that number, plug it in, we get what we call a predicted y value or y hat. From there we have what's called the residual. The residual is the difference between what was predicted and what actually happened. So it's going to be, I always forget the order, it's on your formula chart. I believe it's actual minus predicted. So I'm going to jump back over here. Put the pen down for a minute. Alright, so you're going to take your chart. You're going to look up whatever the number is that they gave you, 24.25. That might not be on this list because it's a different data set. But whatever this number is should be on your list. Wherever it is on your list, you're going to take this number, it's from the table, and subtract whatever you got in your answer here. So it's actual, what actually was measured in the data, minus what you predicted. So this is your prediction, this is your actual. So I believe it's y minus y hat, and that will give you what's called a residual. So the residual is the difference, again, between the predicted and the actual. You'll have to look on your chart. I believe it's actual minus predicted. If this number is positive, then it's above average. If it is negative, then it's below average. So the residual is the difference, meaning that the head circumference of this child is either above or below the value predicted by the regression model. To draw the least squares regression line on the scatter plot, you can kind of just estimate this. It's going to be the line that goes through the scatter plot the best. And you can hit these little plus signs. Mine won't work because it's a print model, but these little pluses will blow them up a little bigger. But the line at best fit should fit right in the middle of all the data points. It shouldn't go flat. It shouldn't go below. Here it goes below. It should go through the middle as best as possible. So you can kind of eyeball this one, hitting those plus signs as needed. Alright, it says notice that two children are this tall. One has this head circumference, one has another. How can this be? So I think C would be your best choice. For children with this height, their head circumferences vary. We know that everyone who's the same height does not necessarily have the same head circumference. So that's a reasonable thing to have. Same height, different head circumference. And then G, would it be reasonable to use this regression to predict a head circumference of a child who's 32 inches tall? So whatever this number is, You want to look at your data set, and if, I'm trying to fit it all on the same page. If this number is within this range, it's okay. The answer would be yes. If the number is not in the range, then the answer would be no. So 32, or whatever your number is not in this domain. I don't see anywhere where 32 is not within these numbers. If it is, it doesn't have to be one of these numbers exactly. This has to be within, between these numbers, between the smallest and the biggest. So the answer would be no, this height is outside the scope of the model. It's possible, but it's outside the scope of the model. So hopefully that'll help you through the rest of the parts. I know these questions are confusing, and if you miss one part, you have to start all over with a new data set. So please be patient with yourself through these questions.